Welcome to episode 10 of the Kiribati 36-foot aluminium sailboat build. In this episode I will be looking at the propeller and the prop shaft and all the little parts that sit around that. I'm doing a bit of an inventory to see what I need to get and how to push that forward. I'll also look at stage 14, which is the Upper Keel Skeleton, and the cost tracking and build tracking of those parts. So let's take a look. Today I will be making a bit of a stock check of all the components I have around the propeller shaft and everything that goes around the propeller shaft, so the whole kind of drive package. So we have a few parts already. We have the actual propeller shaft itself. We have the Cutlass bearing housing. We've got the telescopic propeller shaft tube that the shaft will go through. We've got the actual Cutlass bearing itself, and we got a propeller. Bits about the propeller. So this is, as you can see, a 3-blade propeller, and it is 18-inch. And why did I go for 18-inch? Because that was recommended to me by the propeller manufacturer when I explained what I was going to use it for. So I'm going to take their word for it, because the kind of whole design around the propeller is a bit Chinese to me, so I'm not going to go in too deep on that one. It's made out of something called Nibrol, which is a mix out of nickel, bronze and aluminium, and apparently that is a metal that is heavily used within the shipbuilding industry for parts below water. It has a tapered opening here with a key steel. So I've made one of those, which is a good start. As you can see, the opening is small on this side and it is big on this side, and that's what I meant about being tapered. So it's kind of cone shaped. So when you create your tapered end on the actual propeller shaft, you get some standard machine drawings to work against. They look like this, and they'll give you all the measurements you need to machine it. The propeller is attached to the propeller shaft, or the prop shaft for short, and that is, in my case, a 35mm outer diameter stainless steel 316 rod, which, as I explained, has been tapered all the way down. And then comes a M24, I think, M24 thread here. I've taped it so I'll keep it undamaged if I manage to hit it with something accidentally. And here is the actual key steel that goes in. So I think we have, again, see if that fits. Yeah, so it looks like this. So the only thing that is missing here will be a propeller nut, and the idea is to figure out which one is the best one to get. So they come with a zinc nut, and then no, it comes with a copper nut and a zinc anode. Sacrificing anode is at the end. So if anyone knows any good brands that they've tried before that they can recommend, then feel free to let me know, because I currently have no clue what to go for. So what I'm looking for is the M24 nut with a sacrificing anode, zinc anode attached to it, that is easily replaceable. So the propeller shaft will then run through a telescopic aluminium tube, and in this case I think it's 64 diameter in the outer diameter. I think the wall thickness is 7mm and the inner diameter is 50mm. So that will then go from the outside of the hull and go through the hole, welded into it, and stretch all the way up towards the motors. It will then have some additional parts there as well, such like a CV joint and some other stuff, but I will cover that in a future episode. So at the end of the telescopic tube is the Cutlass bearing housing. So this Cutlass bearing housing will hold the Cutlass bearing, and that is the bearing that will make sure that the prop shaft is spinning freely, and this is something that can be replaceable. So that is then pushed in here, and if I understand it right, people that fit these, or when I come to fit these, you keep it in the freezer for a while, which makes it shrink, and you can probably put some kind of a lubricant on here as well, and then you tap that all the way in here, and then you lock it with these two M6 bolts here on the side. So you can see there's a little lip in there to make sure that it stays on the outside. So one thing I have to do is make sure that this one is welded to the actual telescopic tube, and when this tube sits within the Propeller Skeg, I think I only have 3mm clearance here, so today I need to sand down on both sides of these lines to prepare for a weld, so that the weld is sunken into the material rather than being convex and sticking out, because I don't have a lot to play with here. So I will need to sand this one, and I will need to sand this one as well before I hand it off to be welded. The Cutlass bearing I've gone with is a Johnson Duramax Marine, and it's completely composite. There is no metal parts in this one at all. You can buy them with a harder outer shell, which is probably best for when you use it in for example glass fiber construction, but because mine is going to sit in an aluminium one to avoid corrosion, this one is completely made out of non-metal materials. This is the first time I'm actually gonna try the propeller on the propeller shaft, since the tapering has been done to the shaft. So I'll see how that fits. I would say that fits perfect. Once again, this is my friend Mel who's machined this, and he tends to whatever I throw at it, it just comes back in, you know, millimeter precision. He's such an old school good guy, and it's such a blessing that I've met him in this project. I'm just going to take this measurement. It's good to know when I'm looking at the nut. So we're looking at 28, I think, 29 millimeters. So I guess potentially it could be pushed in a bit further, but yeah, 28 I would say. It's interesting. What I noticed is that a lot of YouTube people that build stuff has a cat or cats. I don't know if there's a correlation there, but it's definitely something I noticed. I will also need to order 2 little M6 bolts, stainless steel 316, and with this being 7mm wall thickness, I assume that if I have some plastic bushes here we can probably do with a millimeter, oh sorry, 10 millimeters of the length of the bolt. So we go 10 millimeter. So when I create the little lip here to weld in, I'm going to go 5 in on both of these pieces, and I'm only going to go 3 mil deep because I want at least 4 millimeter left to weld in to. So 5 mil this way, and I'm going to go 3 millimeter that way. So I'm happy with this one. All I'm going to do is just put a bit of fine sandpaper on the top here, make sure there's no sharp edges or anything, so that I get a flush fit when the weld goes on. So it doesn't look much, but there is a 2 millimeter ditch around here that should hopefully make the weld stick out less. So that makes this one ready for welding. So I'm just gonna go and do a little marker, just make sure that it's not confused and attached to the wrong side of the telescopic tube. In parallel, I've also worked on the actual propeller skeg, so I've started to lay out the parts and try to figure out how far I can weld it and what welding needs to be done when it's actually attached to the hull itself, because there will be parts that needs to be welded, so I can't close it up. So I will probably have to just weld it half finished and then put the final plate on after I've installed the actual telescopic tube as well. Laid out for the first stage of welding. The other outer shell, as well as some of the support pieces that will be sitting here to support the telescopic propeller shaft tube, will have to be welded into position before I close it up, and that will be onto the actual hull itself. What I've also done is printed 2 of these cylindrical tubes, so that I can use that as a guidance when I come to fix the actual telescopic pipe to the hull. That is the same width as the actual propeller shaft. So by putting that in here, having one on each side, I can then run the shaft through there, and I know that the shaft is perfectly centered as I am putting it into its final resting place, and then I can remove and discard of these. Stage 14, Upper Keel Skeleton. Parts and material stood for 51.36%, and that was in Great British pounds 452.75, which is roughly 601.84 in US dollars. External labor came in at 45.09%, and that consisted of welding, which was 260 pounds, roughly $345.63, and the laser cutting of 137.44 British pounds, which is roughly 182.71 US dollars. I also bought some wood to make a stand for the keel because I wanted to hang it upright, and that came in at 3.55%, and that's tools and miscellaneous, and that is 31.27 pounds, which is roughly 37.65 US dollars. You will find links in the description to the itemized cost breakdowns for this stage, as well as the Google Doc showing total cost stages for 1 to 14. Conclusion, Stage 14, the Upper Keel Skeleton. From the total of the 881.46 pounds, which is roughly $1,167.83 of the total cost of Stage 14, I could have saved myself £260 or $345.63 if I did the welding myself. I could also have cut the parts by hand, i.e. lofting, and saved myself another £137.44, which is roughly $182.71, by not laser cutting. These numbers should hopefully be an eye-opener and assist you in your own planning of a boat build. Total spend stage 1 to 14 has now reached £9,464.76, which is roughly $11,367.30, and there's still a fairly long way to go. So one step at a time towards a dream I have carried for many, many years. Thank you for watching episode 10, and as usual, if you have any comments, please stick them in the comments. There was a question about the best propeller nut with an anode to it, so if you have any information around that, then that's appreciated. If you're new to the channel, feel free to subscribe so you don't miss future episodes, and there's also a couple of other playlists, one for the motor build of this boat and the other one is for the electrical wiring, so if that is of interest, that might also be a reason to subscribe. Until next time, I'll see you then, and have a nice week. Thank you.